Hello colleagues, let's discuss today the difference between Autopilot and indoor positioning system. Because we receive quite many questions, can we program your indoor positioning system to control our robot? Well, the answer shall be obvious, but it seems that it is not. So let's do the basics. First of all, any autonomous system, including robots and us, includes three major parts: sensors, brain, which is processing and memory, and actuators. If you have these three elements, it's an autonomous robotics system, and let's say intelligent system in general. So if you translate this to indoor positioning system, then our indoor positioning system actually belongs to sensors. So it senses the location and gives the input information to the autopilot, which is the brain. The brain itself is not capable to, drive your robot or move your copter. So the motors and rotors actually do, but they are stupid, so they need the control, and this control comes from Autopilot. So this is why the answer is absolutely basic and obvious and shall be very, very clear. Autopilot is a brain which makes the decision where to drive, how to overcome the obstacles based on the sensor information which is coming from different sensors. And Mind indoor positioning system is one of those. You can have many, magnetometer, you can have lidars for obstacle detection and avoidance, you can have odometry, you have many different types of sensors. Barometer, if we talk about drones. So those are sensors. Yes, in some cases, like Autopilot, like Pixhawk board, it already has some sensors, like IMU. So gyroscope is there, accelerometer is there, as well as on our beacons, it's there. But you must very clearly distinguish between sensors, brains / autopilots, and actuators, which are motors and rotors. So let's do the same, like a summary. So Autopilot controls, like physically controls, makes the decision, your actuators, your motors, your rotors, your whatever, what is doing things, what is moving your thing. It doesn't have any idea about the location. So this is why, of course, Autopilot is important. Of course, we are important, but only together we do the real system. Standalone, no, you need input. In basic Pixhawk setup, it would be GPS. Okay, you fly indoor, there is no GPS. So you need some sensor input about, where am I? Okay, we give that out of the box. At the same time, returning to the original question, we do provide the real-time indoor positioning system and indoor positioning localization. Sometimes we kind of indoor plus. So you can say waypoints using us, you can get the data from your device and data to your device using our system. So you cannot do this through GPS because you don't have access to GPS, but you can use our system for that. So we are kind of indoor positioning system plus, or GPS plus from this perspective. But we do not control your motors directly. We send the data and Autopilot makes the decision where to go. Okay, I'm off the line, I need to go there. But it's not we do that decision, but Autopilot does. So there are many different types of Autopilot. Okay, the most common, and I'm using this as a kind of an example for all kind of projects. It's Pixhawk based. Pixhawk is, for me, it's like Xerox, all kind of copying machines. So Xerox. In this case, Pixhawk is just manifestation of any type of Autopilot. So when I'm saying Pixhawk, I don't mean exactly Pixhawk. I mean any kind of Autopilot, which consists of the hardware and the stack. And for example, in case of Pixhawk, there are even two stacks, Autopilot and PX4. And they are kind of independent with some pluses, minus, but there are two independent stacks on the same hardware. And you can write your own stack, Autopilot stack, on the hardware. We also have our own Autopilot. Okay, Mind Autopilot. We don't have it as a product for you, but of course we have Autopilot in our own robots. And for drones, for example, we can fly now DJI drones. So we also have Autopilot. And in our perspective, Autopilot is the application which runs on the phone, in this case Android phone, which is connected together with DJI remote control. So that is Autopilot. It's a primitive one from waypoint to waypoint, but that's exactly what customers want. So they want that the drone is flying something autonomously, doing some task like taking pictures, but that's Autopilot does. Based on what? Based on localization data of where am I, means where am I, the robot or the drone, and the waypoints. The waypoints may come from either artificial intelligence of the robot if it's completely autonomous, or typically it comes from you as user. Okay, I want to fly this warehouse on this pattern, or I want you to drive this pattern. So you click waypoints, then Autopilot knows, okay, I'm in this location because their indoor positioning system from our model mind gives this location. I need to drive there. Okay, I need to turn because I have two, for example, mobile beacons, and I know my pose, so I can drive there directly. Okay, I go. Oh, okay, I'm shifting a bit. Okay, I need to turn. That's all what Autopilot does. So this is Autopilot decision making, but based on our indoor positioning system. Otherwise, the Autopilot has no clue where it is. Of course, it can use other systems. I'm not saying so. Sensor fusion is the best. It can be optical. It can be odometry. Of course, IMU in Autopilot, or let's say in Autopilot hardware like Pixhawk, but also in our own beacons. They all have IMU, so they can get the data from both directions and then fuse and utilize the maximum. Drift, noise, all kind of things, and it's always nice to have a comparison between two different systems. So what are the key elements of Autopilot and indoor positioning system? So flight controller, or let's say drive controller, is a hardware. It's a brain, physical brain. So you must run the software or stack on somewhere, and in this case it's typically a small board depending on the applications. This board may have additionally or let's say additional sensors already, so it's Autopilot plus from this perspective, but not necessarily. So at least it must have a processor and the memory to make the decision, and all the sensors may be external, but it's not necessarily like that. So often some sensors are already installed, like IMU, because they are small, cheap, etc. Then you have all these sensors I already mentioned, and electronic speed controller. Those can be external, or they can be on the same board. So they're kind of in the middle, because they may belong to actuators already, kind of interpreting logical signals to the physical signals or data to control the motor or to control their whatever direction. But it may be also a part of Autopilot board or Autopilot hardware. If we're talking about indoor positioning system, it typically consists of three major parts: stationary beacons or anchors, depending on what technology you're using, mobile beacons, which you put on your mobile device, and a kind of central controller, which typically does the synchronization inside the system, kind of controlling the system and sending the data to the external world. For example, in our case, you can get the location data directly from the mobile beacon, and it's typically recommended for autonomous vehicles, because you don't need to run to the modem, then from the modem to whatever computer, then from the computer to this. Sometimes it's possible, but then it adds latency. But sometimes the brain of your robot may be outside. So your robot may be smart, but smartness is in the external computer. Okay, then in this case it's easier to get the data from the modem. So we give you this flexibility. But in general, all indoor positioning systems consist of these three major elements. Stationary beacons, which are kind of your satellites, GPS satellites, what you measure location against what you are measuring the location. And mobile beacon is what exactly measuring the location of your mobile device, because we don't measure location of your robot, we don't measure location or position of your drone, we measure the location of your mobile beacon on the robot. And then we of course assume that it's not moving, so it's not shaking there. So then you know where exactly the point which we are measuring against the robot, and when their accuracy is very high. So it's also important that your mobile beacon is shifted from the center of your robot. So you must take this into account, that we are measuring this location, not central location or mechanical center or whatever physical center of your robot. No, we are measuring this. And even on our own beacons, for example, it's also important to understand that this is, for example, if we are talking about inverse architecture and receiving microphone, so this is the microphone, not this. This is transducer, so this is kind of transmitting center and this is receiving center. So for less accurate systems, like giving you 10-50 centimeters accuracy, it's not important. But for our system, which gives you centimeter level, of course, it's already important where exactly the center is. So this is the center if it's receiving, and this is the center if it's transmitting. So that's their very, very quick, short, and hopefully easy explanation, the difference between Autopilot and indoor positioning system. Autopilot controls your robot or drone. They control your motors directly based on the input data which is coming from the indoor positioning system. Basically localization, to drive from point A to point B or to fly from point A to point B. Thank you very much. Bye-bye.